Half the reason is for that, but the other half is so we can protect this road. If we didn't have that water crossing there or the tyre wash, we would track a dirt onto this road here that we have to sustain every day, and we wouldn't be able to sustain it if it was dirty from all the dirt that we track onto the road, because it would just speed up the melting too fast. And in fact, the cleaner this road is, the slower it melts, so it's actually melting slower than next to the road. About 18 kilometres per hour. Not much at all. If we put it in neutral. I tried it down that steep one. Now from here guys, at the end of the valley, you'll see there's a big wall of ice up there. Now beyond that point is the Columbia ice field itself. Now it is just a massive body of ice and snow, and at that point at 3,000 metres above sea level, just plateaus out with this ice field here. Now it is 325 square kilometres in area, or 125 square miles. So no small ice field up there. It's actually the largest ice field in North America and America. So now it's also surrounded by 11 of the 22 tallest mountain peaks in the Rockies, and that's a good reason as to why the ice can sustain itself here, as it doesn't just hold in all that ice. They actually force wind to rise over the ice field, and as it does, it cools down and it releases all of its moisture in the form of snow. That's actually how glacial ice is formed, is the accumulation of snow over time. And it actually takes about 12 metres or 35 feet of snow to create 1 foot of glacial ice. So it's very, very dense. Now the Athabasca, the one we're on right now, is about 5.5 kilometres long, 1 kilometre wide, and like I said up at the turnaround point, 300 metres thick. That's going to be a little bit of a bump just here. Now up to our left, about 9 o'clock there, is another little glacier known as the AA Glacier, and this is a hanging valley glacier. Now it gets its name because it is literally hanging up there in between the Athabasca Mountain and the Andromeda Mountain. And then back in 1843, that glacier stretched from right to left and joined on with the Athabasca. Now everybody on the left side, I just want to show you something here. This is a mill well where all that water is running down into that hole there. That is a mill well. So if you all stay on the same side that you are on, everybody on the right side will be able to have a look at it on the way back. Now we've got another little type of glacier known as a cirque glacier on the Andromeda Mountain, and gets its name from the Latin and French derived word for circle, and that's because over hundreds of years, or thousands even, that glacier has advanced and receded, and gravity pulling it down the mountain has carved this massive circle into the side of the mountain there. Now those two glaciers up there are a little bit different to the Athabasca. They are independent or self-sustaining, so they have to rely on their own snowfall to create their glacial ice. Whereas the Athabasca does get a little bit of ice from its snowfall, but generally relies on the ice field to overflow into this valley, feeding it its ice. Now from this point you can see there's 3 steps in the head wall of the Athabasca, and in those steps are massive crevasses which stretch from one side of the valley to the other and can be 8 metres wide and 30 metres deep. So that's big enough to fit 2 of these buses side by side and about 5 or 6 on top of each other. So that's why we stop here and don't really go much further. just a bit too dangerous up any further than this.